And welcome to today's functional skills webinar on handling data as part of level 2 maths. As I mentioned before, there'll be some questions throughout, and if you do want to interact or ask anything or want anything clarifying, please just use the chat box that we've mentioned and we'll take questions either as we go or possibly save them to the end. My colleague Eamon is online as well, so she'll be looking at those questions and raising them for you. So in terms of handling data, it's a key part of functional skills maths, and there are two key main areas to it. So what we're going to look at in the workshop is those. So the first thing is to look at data to calculate averages and range. I'll explain these terms as we go on. The key at level 1, you'll be asked to calculate average and range. The key at level 2 is to understand what you're calculating, what the data shows, and why you're using that type of calculation. So that's one of the key things to look at, is understanding the outcomes for those results. We'll then look at the grids, tables and charts that you'll be using in two ways. One is getting information and interpreting information from them. The other is to create graphs and charts, and to do that, ideally you need to know the difference in continuous and discrete data as well, so I'll cover that. So we'll look at averages and range first, and then we'll go on to the grids, tables, charts, graphs, whatever word you want to use to describe them. So range and averages. Range is a mathematical calculation that you can work out, which I'll go through with you. There's also what's called the average, but there are actually three types of average that you can calculate, and they are known as the mean, median and mode. Often when we talk about average and working out the average, we're usually talking about mean, but actually there are three types of average, as I say, mean, median, mode, and we'll go through what these are, how to use them, and what the outcomes show you from those. To be able to work out any of these, you need some data. So I'm going to ask you to get some data. We're going to look at the age of some famous people. So first of all, we've got David Beckham, if anybody would like to guess how old he is. David Beckham is actually 44. So some good guesses there. I won't get you to guess all of them. We've got Adele, who's 31. Alan Sugar, 73. And Her Majesty the Queen is 94. On the next screen, we've got some ages. We've got Oprah Winfrey. Anybody like to guess how old Oprah Winfrey is?
56. 65, 67.
Oh, some good guesses there. Some good guesses there. She's actually 66.
Oh, wow.
Actually 66, some good guesses. Probably the best picture of the lot, I think, is Elton John, who's 73, same as Alan Sugar. You can decide who you think looks best. We've got Beyonce, who's 38. And last one, you can have a guess again. Barack Obama. Any guesses on him?
54, 56, 56 again, 40.
Oh, 40 is a good guess. No, much too young, much too young. 58. 58 is, and he does look good for it, I'll give you that. So we've got some information there. We've got some data that we can use, and then we need to do different things with it. So one of the first things we may have to do is look at the range for data. And range is simply working out the difference between the highest and the lowest figures in a set of data. So we've got our data and we need the highest and the lowest. We were talking about ages though. So our highest is going to be our oldest person, which is the Queen at 94. And our youngest person was Adele at 31. And we need to find the difference between them. Now in maths, I always say this, there's only 4 things you can do. You can add up, take away, times or divide. You have to do different things with them and know the right time to do them. But there's only 4 things you can do. And when you're working out the difference between numbers, what you want to do is you want to take them away. So you want to take the highest, take away the lowest. So if we did that in here, we'd have 94, take away 31, which is 63 years. So our range in that set of data, the answer for that is 63 years. And the maths calculation is simply the highest number, take away the lowest number. Doesn't matter what you're working out, whether it's to do with temperature or number of purchasing a shop or amount of money or time, you always get the highest number and take away the lowest number, and it'll give you an answer. One of the things, so that's how you do it. I mentioned that you need to look about how to understand these things. So with range, what we're checking is, it says there, the difference between the highest and lowest, or the spread of the information. So one way to think about range, you think about like a firing range where you'd shoot something from the start to the end. And the longer that distance, well, so the bigger the number, the longer that distance. So when you're looking at range, if you needed to compare numbers, here we've got a range of 63 years, which out of 8 people is quite a big spread. If we didn't have the Queen and everybody was in their 30s, our range might only be 6 years. And obviously a smaller range means a smaller spread of people. So when you're looking at the range, to do it, you do highest number, take away lowest. But what it shows you is the spread of the figures, how spread out the figures are along a line, if you think. So I then mentioned these 3 different types of average. The mean, sometimes known as the true average. And quite often, if you say to people, how do you work out the average, they will tell you this answer. And it is actually called the mean. And what you do for the mean is you add all the numbers up and then divide them by how many there are. So I put all our numbers there and I've added them up quite quickly to save us having to do it. I will give you lots of examples after the workshop for you to work for yourself. So there's the total number. Add them all comes to 477. We then divide by how many there are, and there were 8 people, and the answer is 59.6 years. So that is our mean. What we're working out by the mean is what we're saying is if we take out all of the years and spread them equally amongst each person would be 59.6 years. So really what the mean is showing is the evening out or the spreading out of the numbers equally amongst everybody. A learner gave me this many years ago, how to remember the mean. They remembered it because it was really mean that you had to do two things. You had to add all the numbers and then divide them. And they felt that was really mean because it was 2 things to do. So that's something that stuck with me for a number of years from a learner. So that might be a useful way for you to remember it. And the mean, if we look at the answer of 59.6 years, well, if we look at the spread of our numbers, we've got a couple of 30-year-olds and a 44. But then they're all a little bit higher. So we've got a 58-year-old, 2 73s, 66, 94. So we would expect our mean to probably be slightly towards the higher end, which 59.6, almost 60 years is. If we'd worked it out and we got the mean as 32, obviously that couldn't be correct because that doesn't represent the spread of our numbers. Or similarly, if we got the mean answer of 84, again, that doesn't really represent the spread of our numbers. So one thing you can do when you're working out the mean is just do a sense check. Does 59.6 years sound about right? And actually, if I look at those numbers, it probably does. If we'd guessed, we probably would have said mid to late 50s, just looking at the numbers of spread. So the mean includes all of the figures. You take all of the figures and add them together, divide by how many they are. And as I say, the mean is showing you the spread out of numbers or evening out of numbers. The next type of average I mentioned was called the median. And the best way to do this, you need to find the middle number. So the easiest way to do that is put the numbers in order, which again, I've done nice and handily in advance. And then you simply find the middle number. You put them in order and find the middle number. Just going to show something briefly off this presentation that I've got. So these are our numbers, but I'm actually going to delete the Queen. Sorry, Your Majesty, but you think the Queen's gone. So I've actually only got 7 people now on here. So if I were to try and find the middle number, I'd cross out the first one, cross out the second, the end one, and the second from last, next. And you'll see I'll end up with a nice real finger and a middle number, and our number is 58. So if I've got an odd number of people or odd number of figures, I can find the middle quite easily by simply putting them in order and reducing them down. We haven't here because we've actually got an even number of people. So if we cross the first 3 and the last 3, we're left with 2 numbers in the middle. So our median is actually somewhere in between those 2. And all we want to do is find the halfway point for those 2. And the easiest way to find the halfway point to 2 sets, 2 numbers, is to add them both together and then divide them by 2 to find the halfway point. In this case, it would be 62 years. So the median is simply finding the middle. You may be able to just put them in order and cross out until you find the middle one. If you've got 2 numbers in the middle, such as we've got there, when we use an even number of figures, simply add them together and divide by 2 to find the halfway point. Here about the median is it's ignoring a lot of the numbers. So we've ignored the first 3 and the last 3 here, which sometimes is really useful. I would say in this case, probably not, because there's no reason to ignore people. All these people are as valid as part of the group. If, however, we had these figures and suddenly we had a 3-year-old that we put in here, that would obviously, our mean previously, that would obviously massively reduce that because we've got a 3-year-old that's bringing the numbers down. So in this case, that would probably be useful to use the median. Median gets rid of any outlying numbers. So if you have got an extreme low or extreme high, by using the median, you're basically not including that one. You're just crossing it out straight away. The median is very useful if you've got extreme values. The mean, as mentioned before, uses all the figures. So if you want a true representation of it, you'd use the mean, but the median is quite good if you've got some strange figures. An example some of you will have seen in practice questions and tests is if you're looking at times that people do a 10K running and the runner wants to know their average time. But let's say one week they had a cold, as they just weren't feeling up to running, so they took double the amount of time they would normally do. Well, if they worked out the mean, it would include that figure, which would skew their figures a little bit. If you use the median, the first thing you do is, well, I'm going to cross out that one because it was much higher than the others and cross out the smallest one and find the median. So the median and the mean are useful in different scenarios. The third type of average that I mentioned is called the mode. And this is simply the number that occurs the most often, most occurring. Easiest thing to do again is put them in order. It's easier to see. And then simply in this list, we've got 2 73-year-olds and only 1 of everything else. So our mode is simply 73. So mode is one of the easiest to work out because you haven't got to do any calculations. It is useful to put them in order. I'll be honest, mode isn't the most useful information either in terms of an average. It's lot rarer that we use the mode to work things out. Mode can be good if we want to look at tendencies. So the best example I've ever thought of, come up with, is to think about a shoe shop. They were looking at how many shoes do they sell and what sizes are they. If they worked out the mean, they might work out that the average shoe size is 7.2. Well, that doesn't particularly help them at all because there isn't a 7.2 shoe. If they worked out the median, it'd be ignoring everybody who bought small and low numbers, so that probably wouldn't help. But in shoes, though, if they know they sell the most size 6s, they're going to order more size 6s than they are the other sizes at the end. So if you've got a very specific information that you want to see the tendency for, the mode's useful. I would say in this case, in terms of our ages, it doesn't really tell us anything that the mode is 73, because it tells us nothing about the other people, but is useful to work out. If, incidentally, if we also added another 31-year-old to this, we would have two modes. So the mode would be 31 and 73. So you can have a number of different modes if need be. It's the number that occurs the most often, but there can be more than one of them. Just to recap, the range is the difference between values, and to work out the difference, you do the highest, take away the lowest. The mean is evening out, so you add them all up, divide by how many they are. Median is the middle value, easiest to put them in order first and then just find the middle one. And then the mode is the most common. I've mentioned mean is mean because you've got to do two things. Median sounds a bit like medium, so that might remind you of the middle. Mode starts with MO, and you might remember that leads to the most. There is another technique that some people use for remembering it, and it's a little rhyme. And I often don't use this simply because I can never remember what the tune is, but I've practiced this once, I have remembered it. So if this doesn't work for you, I apologize for I'm not going to sing my sort of slight singing, but some people it does work really well for, and it's actually to the tune of Hey Diddle Diddle. So the rhyme is Hey Diddle Diddle, the median is the middle, you add then divide for the mean, the mode is the one that appears the most, and the range is the difference between. So I've had a number of learners over the years, I've remembered this and sat in tests and I've heard them humming it under their breath and things, and that's absolutely fine. But as it's just there, Hey Diddle Diddle, the median is the middle one, you add and then divide the numbers for the mean, the mode's the one that's there the most, and the range is the difference between the highest and the lowest. So that might work for you if you can remember the tune. I often try to sing it to Humpty Dumpty, and it doesn't work. So it is Hey Diddle Diddle, if you can remember that. There is one extra type of average that I want to mention to you, and it's about what's called group frequencies. It's a little bit more difficult, this one, a bit more detail to it, but it does come up. You will only be asked to, as far as I can tell, only be asked to work out the mean for group frequency. So you can work out the mode and the median, but the mean is the only one that you should be asked to do. So let's take this example. There's a takeaway restaurant that records the number of orders it receives each day over a month, and it puts them into groupings. So on the days that it was ordered, between 1 and 10 orders happened 6 times. It had between 11 and 20 orders on 8 different days, 21 to 30 on 12 days, 31 to 40 on 4 days, and 41 to 50 orders only happened once. So we don't know the actual number of orders. We know the categories or the grouped frequencies that they're in. The way we work out the mean for that is we need to work out the midpoint for each of those orders. So if we take 1 to 10, instinctively we might say that the midpoint is 5. It's actually 5.5. And if I can open a Word document to show you, let's get down here. If I show you the numbers, oops. So hopefully you'll be able to see this. So if we do the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we want to find the middle one. So let's delete the first 3. Let's delete the last 3. Let's delete another one from each end. We're actually left with 5 and 6. And as we said with our median before, the midpoint of those two would actually be 5.5. The other way you can work out the midpoint is adding them both together. So 1 add 10 and divide by 2 would be 5.5. So we need to find the midpoint for each number of orders, and they are there, and the frequency, and we multiply that by the frequency, which gives us these figures. So 5.5 times 6 is 33, 15.5 times 8 is 124, and so on. And we've ended up with a total of 31 orders, because it's each day over the month, and the total number of orders was 650.5. To work out the mean, we know we take the total and divide by how many there are. And if we do that here, we get the figure of 20.98. So I've rounded that up to 21 orders. So that's a little bit more detailed, simply because you've got to find the midpoint for your detail, and then you're multiplying it before you can work out the mean. As I've said, first of all, I'll send out this presentation. I will send out a specific link for some more information on grouped frequencies and also some practice questions as well. But that's a little bit more detailed. I would suggest that one. So that's looked at the average and the range. The other thing we need to look at is different types of tables and charts that you may come across in terms of handling data in terms of functional skills. So the first thing you might come across is a coordinating grids. For those who are aware, functional skills changed last year, and some of you are actually doing on the old version and some are doing a new version. If you're not sure which, I could tell you afterwards. And it doesn't make a massive difference. I do know that the new version definitely, regularly asks questions on grids. It's less likely on the old version. It can come up, but less likely. But the new version, if you know, or if you're told you're doing the new version, you'll probably almost definitely get a question on coordinates. So if we've got a grid like that, there's a few things to note. First of all, the x-axis goes across and the y-axis is vertical, goes up. And if you think of x is across, that might be a way to remember that x goes across. So x is going across and y is going up. Whenever you see coordinates, they're usually written in brackets with a comma between them. And the first coordinate is the x and the second coordinate is the y. So it would look like x, a number, comma, and then another number. Again, a way to remember that it's x and then y is x comes before y in the alphabet. So the x-axis goes across because it looks like a cross. And remember that the x is always first in the coordinates because it comes first in the alphabet. Final thing to note is that the plus figures, positive figures, are always right and up from the middle, and the negative figures are left and down from the middle. So I'll go through the examples of those different dots on the screen. Hopefully that'll help. So if we take the red triangle, if you can look on your screen, it's hard for me to point this out, but you go along 3 lines on the x-axis or 3 blocks on the x-axis, and then you go up to number 4 on the y-axis. The coordinate for the red triangle is 3, 4. X is 3, y is 4, so it goes. If we look at the yellow square, we go backwards along the x-axis 3, so it's -3, and then we go up on the y-axis to 2. So the coordinate for that is -3 and 2. For the blue pentagon, we go along the x-axis backwards 5, and we go down 2. So the actual coordinate for that is -5, -2. And then finally for, well, actually, before I click it, can anybody suggest what the coordinates would be for that green dot on the screen? So remember, x is first and then y. Anybody in the chat? That's what they are.
We've got 5 to 1.
Any others? So we need the x figure first.
We've got 1 to -5, 1 to 5, 1 to -5, and 1 to -5 again.
Brilliant. So so we're going along 1 on the x-axis, so that's 1, and then we're going down to -5 on the y-axis. So it's actually 1, -5 to give yourself a brownie point if you got that. So they are a little bit difficult in terms of coordinates. Not something I always say that functional skills is about everyday functions, which it is. This probably isn't something you come across every day, but it is worth researching. Won't have to do much more than that, and either plotting the points or identifying the points, but it is worth remembering those key things there. Other type of tables are maybe a little bit more straightforward and the kind of things you probably do see more regularly. So sometimes you'll get a chart or a table like this that just gives pure information. And it might say this is a section of 4 different cars with information on their colour, their miles per gallon, the cost and the fuel they use. And you might be given some scenarios. So the first thing is you've got £17,000 to spend. Well, if we look, all of the 4 cars are under £17,000, so that's fine. You want a petrol car. Car C is a diesel, so we can cross off car C. We know it's not available to us. You want it to do over 35 miles per gallon. Well, if we look at car A, that does 32 miles per gallon, so we can cross that out. And you don't care about the colour, and so it doesn't matter what they are. So actually, out of those 4 cars, there are 2 potentially that you could purchase, B or D. And the question will say, which car do you think you should buy? Now, again, we need to think practically with this. Potentially, both of those are correct. It doesn't matter whether you choose B or D because they both meet our criteria. Personally, I would say looking at that is car D does less miles per gallon and is more expensive. So I'd probably go with car B because that's better. But you may say I'd go for car D because the miles per gallon is pretty similar. And by spending more, you're probably getting a better quality car. So I'd spend more, that little bit extra, £2,500 extra, and go for car D. So there'd be no right or wrong answer to those 2 as long as you didn't choose A or C. So what they're looking for you to do is, do you eliminate 2 of them and then either choose the only one remaining, or if there's 2 remaining, again, think functionally, choose which one you would buy and why you would buy it. So you may get a chart like that, just simply looking at information that you've got to decide, pick something from and choose which one you want to buy or use or whatever it might be. Another type of chart you've got, this is called a tally chart. You may have seen these and use these regularly. So this example is asking us group of school kids what pets they owned, and we can see the tally chart works like that. Ask how many we've got: rabbits, dogs, cats, goldfish and hamster. If you haven't seen these before, if we look at cat, when you get to 5, lines go down individually as a count. When you get to 5 lines, you sort of draw that line across. So in cat, you can see there's 2 gates of 5 lines. that would be 10, and then 1 on its own, so that would be 11. For dog, there's a gate of 5 and 3, so that would give us 8. So hopefully most of you will have seen those before. So there may be something straightforward. How many people own animals with 4 legs? I had a debate with my son yesterday. A rabbit, dog, and cat we were okay with. We had a debate whether hamster's got 4 legs or 2 legs and 2 feet. I think they're legs. So I won't share that, so you just add this up. We're not going through percentage or probability today, but we will do those at other times. So you may be asked what's the percentage of the pets are rabbits, or if we picked an animal at random, what's the probability it's a goldfish? So there's a little bit more maths to be doing there, but we're still using the data from the tally chart. So tally charts do come up quite regularly as well. This is sometimes known as a pictogram or a pictograph, and basically it's a chart, a bit like a tally chart, but it uses pictures to display something. And so again, excuse me, you may get a relatively straightforward question. How many yellow Smarties are there? Well, if we look at yellow, it's got these circles, and the key at the bottom, and there'll always be a key to this, shows that a full circle equals 2 Smarties. So we've got, in yellow, we've got 2, 4, 6, 8, 10, and then we've got half a Smartie. We said 1 circle equals 2, so half one's going to be 1. So actually we've got 11 Smarties there in yellow. If we look at blue, we've got 5. We've got 2 full 2 circles and a half one. So you may be asked to something straightforward than that. Again, something we'll look at another time. We actually looked at a previous webinar at fractions. It might say as a fraction, what proportion of Smarties were pink? And again, if we pick one of the Smarties at random, what's the chance that it's either red or purple? So that's probability, which we will do in a future webinar as well. Incidentally, I'm going to ask when I send this out afterwards, if anybody wants to answer these questions, then they can do. So it's a bit of practice for you. So look out for that when I send it as well. So a pictogram, pictograph, pretty much mean the same things. You won't probably have to label what it's called, but you may have to take information from it. Before we look at the final section, which is what type of charts that you have to use. And by charts, you may have to use them to get information, but you may also have to produce them. I'll come to that in a little while. There's 2 different types of data. And it's not too important to remember them exactly, but it's useful to know before we look at the charts. There's something that's called continuous data, which can be any value within a set of numbers. So if we're looking at somebody's height, that could be anything at all. If we're measuring in centimeters, it could be any number of centimeters between the smallest person in the world and the oldest person in the world. And you could do 0.5 of a centimeter or 0.05 of a centimeter. So really, measurement of height or something is continuous data. Discrete data only looks at specific number of values. So if you were to look at how many children somebody has, they're not going to have 3.2 children. They're going to have 3 children or 4 children or 5 children or 1 child. So there can only be certain numbers that you can have within that range. And that's called discrete data. So some more examples. A continuous data could be the volume of milk produced by a cow, because we could measure it to anything. But actually the bottles of milk sold in a shop can only be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. You can't sell 7.4 bottles of milk. Continuous data would be the average daily temperature, because we could round that to anything. Whereas actually the number of days with temperature below 20 degrees, again, that's a set number of days. You can't have half a day. And final example, a continuous data might be the diameter of a tree. But actually the number of trees in a forest is discrete data, because there can only be there's either a tree or there isn't a tree. So continuous and discrete data, again, you're not expected to define these or describe them, but it's useful just to know that they exist. You'll see why now. So the different types of graphs or charts you may have to produce. You may be given these to take information from, but you actually may be asked to produce them as well. First of all, maybe a bar chart. This tends to present and compare discrete data. So we'll have set figures that we'll put in there. You can use it continuous data, but generally it's about presenting discrete data, set figures, and comparing them. You'll see a bar chart example in a moment. A line graph tends to be more continuous data that changes over time, because you plot points on a line as they change. And again, we'll see an example of what that means shortly. A scatter graph can show either type of data, and generally it's to see if there's a pattern. So a line graph will be something that changes maybe over a week, a month, a year. Scatter graph is a bit more random, and you're looking for a pattern within there. And the final one you might be asked to do is a pie chart, and pie chart tends to show proportions of a whole figure, as I will explain now all of these. I'm going to go on to show you them some completed examples. In the test, the functional skills test, it's computer based. And if you're asked to produce a graph, there is a piece of software on there that you can produce with it. There is actually a separate video on our YouTube channel that shows you how to produce the charts. It's not the most difficult, it's not the most technical piece of kit software to use, but there are some little things that are useful to know. So I would recommend, once you've thought about how you're going to produce a chart, if you can watch that video, and you will get a chance to practice before your real test, actually producing a chart using that software. So looking at the different types, this is what a bar chart looks like, and you'll see these. I've done this for the age of 4, the people from our original list. And you'll see that we've got a key on the top right hand side which says the Queen is blue, Beckham is green, Obama is that purpley colour, and Beyonce is a dark orange, as that is. So there's a number of things that I've got on here that you need to include when you're producing a bar chart. First thing you notice, my axes are labelled. So my x-axis along the bottom, and it says there that these are famous people. And on the left-hand side, I've got age in years, and I've put the numbers on there to show, and I've gone from 0 up to 100. On that, it's useful or important that you do always start at 0. It is possible to produce charts that don't start at 0, but there's an extra little thing you need to do for that, and you can't do that with this software. So the markers, the examiners do expect you to start at 0, no matter what your scale up. Whether it goes to 100 for age or whether it goes to 5,000 because it's to do with profits, you would still start at 0. You'll notice that the bars that I've done, you can drag the bars up to their level. Some of them are probably slightly bit out because it's a bit hard to see on the screen, but as long as it's approximately right. What I personally suggest is you put those little text boxes above each bar that shows the number. So the Queen is 94, Beckham is 44. They're not essential, but if the marker's unsure whether you've put the bar in the right place, that just shows to the marker you know what you were trying to do, and so I would recommend that as quite a useful thing to do. I've already mentioned the key, which is color-coded on the right. Instead of the key, I could have put people's names at the bottom. So I could have put the name of the Queen under the blue bar or Beckham under the green, but it's easier to do the key. And one important thing, top right, is I've got a title, very short, bar chart showing ages of famous people. So all I need to do, but I've got the title. So that would hopefully get me full marks if this was a practice test. Was a real test. The labels on the axes, the numbers starting at 0, the bars with the numbers on top of them, the key and the title. So that's a bar chart. And as I said before, a bar chart enables us to see that where people are and compare people from different levels on the bars. The next one I mentioned is a line graph. Now, again, the setup of this is fairly similar. I've got months along the bottom. I've actually labelled the different months of the year. On the left-hand side, I've got sales figures in pounds. I've started from 0 and gone up to £2,000. And I've put a title, top right, line chart showing the 2019 sales figures. And then I've plotted the points on the graph, which, as I say, if you watch the other video that I've mentioned, that will show you how to plot those points. And the line is drawn automatically. So the thing about a line chart is it joins all the dots up. So you can see the pattern over the year. So we can see in this made-up company, sales increased up towards sort of springtime, dropped down over summer, and then started increasing again once you got to winter and Christmas, and then drops down again. So this would be a useful example of a line chart and showing the pattern that this company goes through in terms of its sales. Similar, but with some different tendencies, is a scatter graph. So again, labelled pretty much the same way. Numbers on the left-hand side starting at 0 and a label for temperature in Celsius. Bottom is labelled as days of the week with the day labels. MT, WTF is fine rather than Monday, Tuesday, Wednesday. You don't have to write it in full. Top right, I've got a title. It's a scatter graph showing daily temperatures, and then I've plotted the 5 points, which are in red. You'll see on here as well, there's also a black line, which is called the line of best fit, or sometimes known as a trend line. This definitely comes up in functional skills tests, either asking you to draw one or for you to discuss what does a trend line show. So a trend line, as it suggests, shows the general trend of the points. What you want to do is you can't join up all the points because then it would be a zigzag line. What you want to try and do is draw through as many points as you can, having an equal number of points above the line and below the line. It's not essential to get the line exact. You want a more of a general indication of what's happening. So if you look at the one I've drawn, and I'm not saying it's perfect, but the lowest, the far right temperature is almost on the line. I've got then 2 above the line and 2 a little bit below the line. So they're sort of equally spaced. There is a way in maths that you can work out exactly where the trend line should be, but it's a very difficult, complicated calculation, and you wouldn't be expected to do that at all. You're expected to draw a line that would generally show, and what this is generally showing is over the week, the temperatures generally drop down. It's not much of an indication only during a week, and I can see that Wednesday does go up a little bit, but generally the temperatures are decreasing as the week goes on, is what we're showing. That's called a trend line or line of best fit. One of the more difficult things to try and put onto the graph. But again, it's not about joining all the points, and it's not about having it exactly where it should be. It's having a general indication to show are my points going up generally or going down generally. And the final one to mention is a pie chart. So a pie chart is very useful if you want to show proportions, usually in percentages as we've got here, between a whole. So this is a pie chart, as it says in the title, a pie chart showing how people commute. So out of 100 people in the office, we asked 100 people how they commute, and we got people to choose car, train, bus, or walk. And you can see 44.2% people chose car, 30% chose train, and then you've got bus and walk as well. So we've got a whole outcome, which is all our people in the office, and they all chose one different way that they could commute. So a pie chart, as I mentioned before, is about proportions of a whole figure. A whole figure in this case being everybody in the office, and the proportions usually best in percentages. You can do it with fractions and other things, but it's usually best to work out the percentage. So you'd be given the data, it could be in a tally chart like we saw before, and you'd work out the percentage to say, yeah, 44.2% of people go by car. And within the testing software, all you simply do is drag the line until it says 44.2. And it puts that in for you. So the figures are already put in for you, and this one of the lines are done, which is nice and easy. The key thing you've got to do is put in a title and a key, and obviously get your figures right, which are usually percentages. So the main types of graphs I mentioned there's a bar chart, which tends to be presenting data that you want to compare. A line chart, if you want to show data that flows over time and how it changes. A scatter graph shows data that could be spread out, but you're trying to see if there's a pattern. And pie chart is about proportions, usually percentage of a whole figure. So quite a lot to go through in here. And I think one thing with this compared to some other webinars is I haven't got much calculations that I can show you. They've done on the screen because it's not necessarily about the calculations. If we take mean as an example, you're adding all the numbers up, and then when you've got the answer, you divide by how many numbers there are. When you've got a calculator, that's not a hard thing to do. Even if there's 20 things to add up, if you've got a calculator, you add in 20 things up, press in equals, then divide by 20. So the actual calculations aren't that hard. The key with things we've gone through here is knowing what to do at the right time and why you've chosen mean rather than median, or what the rate. If the range says 73, what does that mean compared to a range that says it's only 4? So it's the what and the understanding more. So what I wanted to go through is how you calculate things, but also how to understand what averages and range mean. To give you some interpretation of how you get information from grids, tables, charts, whatever you call them. Slightly knowing the difference between continuous and discrete, which is just useful when you're thinking about the chart to produce. And then finally, the key components in producing graphs and charts with, as I've said, an extra video that I'll make sure I put in the email to you, where it actually shows you how you do that on the software that's involved. So thanks very much for listening today. I'm going to stay around if you've got any questions. If you want to ask them on the chat, or if you want to put your microphone on, you're very welcome. And myself and Eamon are here to answer them. But thanks very much for listening.
Perfect. We've had questions coming through, Paul. Georgina's asked, when we did the averages, can you use a calculator in your exam? So
I mentioned before there are two types of functional skills that changed on the 1st of September. The old functional skills, you can use a calculator for all questions, so there's no issue with problem there. The new functional skills, there are 15 questions without a calculator, and then 15 questions with a calculator, and mean average can be in either of those. When they're doing the section without a calculator, again, they're checking that you can calculate, so they're not going to make it a really stupidly complicated calculation. They will give you numbers that are relatively easy to add up and then relatively easy to divide, but it could come under the calculator or non-calculator. If you're in the new functional skills, if you're in the old functional skills, not an issue. You get to use a calculator for everything. Again, if you're not sure which they are, ask either myself or Eamon, whoever your tutor is, and we'll be able to tell you. If you started before September last year, you're probably on the old one. If you've started since September last year, you're definitely on the new one.
Perfect. And we've also got Joe, who said, after you just did the graphs part, do you use Excel for this on the actual exam?
No, it is their own inbuilt software. It's a lot more basic than Excel, which is a good thing. However, there are a couple of things. So on the charts that I've done there, on the left-hand side, you can see the numbers of the age in years. You can use a little text box to put all of those in, but actually there's one button that you click where it says show numbers, and it shows the numbers automatically. So you can either spend 5 minutes faffing about with text boxes and getting in the right place, or you can click one button, but you need to know where that button is. As I said, there is another short video, I think it's only 7 minutes, I think, that shows you how to do that. I may have mentioned already, but we have a practice test system that is exactly the same as the real test system. It uses exactly the same software. So when you're ready to do a practice test, if you haven't done already, we'll get you on that software, and you can have a play with the software because you can't break it. So that means when you come to the real test, you will have seen the actual software in place, and actually we have a practice of it. So it shouldn't be an issue when you're in the actual test, but we can give you access to that, both as a full practice test, or if you want to just go to the charts question and have a play about with that, you can. Yeah, it's not, some people don't like it. I obviously see it quite a lot, so I'm used to it. So I think it's okay. But when you first see it, you think maybe some of it isn't as intuitive as you'd like.